I'd like to present the next group up. They're going to be speaking on Redfish host interface, UEFI, and OS implications. We have Samer El Haj Mahmoud. He is software technologist at Lenovo. And John Leong, principal engineer at Intel. And Mike Rothman, engineer at Intel and chair of the UEFI configuration and shell subteams. Thank you.
All right, so I'm Mike Rothman, and I'm gonna actually, so I guess I'm speaking as a configuration subteam person. So I'll be actually doing the introductions for a lot, these guys lead you into their content, which is gonna be the dark and deep technical stuff on the host interface. I'll actually cover some of the, some of the agenda. So I'll talk about some of the new interfaces that came out in the UEFI spec, and also basically what the plans are with doing something with that. That'll just essentially lead into some of the host interface discussion and demos and stuff like that. So mine will be actually pretty quick. Famous last words. So, so I think Jason gave a good introduction of what Redfish is. It's really, a lot of this manageability built on existing tools, kind of web interfaces that folks are fairly familiar with. Suddenly I'm sounding a lot louder. And let's see here. So we recently put out UEFI 2.8. Has a lot of new interfaces. Jason made references to the REST EX protocol. So we have RESTful APIs available, service binding to create children, so you can go ahead and access the actual devices, the SMBIOS Type 42 devices, Redfish to discover your Redfish service. We've got the JSON protocol that allows you to go ahead and convert JSON into kind of the underlying configuration data that we have in UEFI. So a lot of that, I think yesterday Zach talked about some of the HII stuff, so I guess somewhat to blame for a lot of that stuff. But how do we convert from all the configuration that we're normally carrying in the platform firmware? How do we convert that up into some JSON structures that other people can understand? And then also, how do we get instructions coming in that are coded in JSON, and how do we convert that into something that we know what to do with? Actually, Jason touched on a couple references. So we added some of the ability to go ahead and decorate the form sets, which are basically our configuration pages, to indicate this is something that we want to expose to REST interfaces. And you can do that actually at the page level or at the question level. Roadmap. So I guess the order of this is probably a little odd, but so we did check in some code to open source on Tiana Core. There's a URL at the end of this, but kind of the expectation is we want to get people to take a look at some of what we're doing. So a lot of this Redfish UEFI stuff started 2+ years ago, and it's actually been a pretty collaborative effort because we had a lot of involvement from a lot of the companies, especially those that deal with platform configuration. So obviously, Lenovo's represented, HP's represented, Dell, et cetera. A lot of people have been involved with that. And for the most part, we've checked in something that gives a good baseline of, it's kind of the culmination of what we discussed, what we're going to do, what is UEFI on Redfish. So it's kind of a starting place where everyone can go ahead and take a look at what that actually means from a Redfish, translation to HII back to Redfish. And we're definitely looking for collaboration. If there's people who have opinions, input. And this is actually one of those strange scenarios where we're kind of crossing the streams. We have a work registry between DMTF and UEFI formally. So, so there is going to be a lot of cross-pollination between things that are evolving in UEFI from a spec perspective and from a code perspective. as well as evolving in DMTF. So we definitely want to get, I think Jason had, a call to action to get more participation in DMTF. I'm probably guilty of that as well. I should be there more often. But nonetheless, I think, more participation is always welcome. And, we're trying to get it so that right now it's in a staging area. So we're trying to get a lot of, co-engineering, get community involvement so that we can actually put that into EDK2 master. Some of the features, so I'll just go through it real quick. I don't want to take up too much time from these guys, but so you'll see the use of the REST-EX. You'll see configuration pages that are decorated with some of the new REST style hints for the form set and also at the question level. Support for several of the Redfish interfaces. And you'll see a couple of protocols, support for certain schema. You'll see some usage of the keywords that Jason also referred to that are up in the registry on the UEFI website. So you'll see some of that code actually exercising some of that information, like the iSCSI keywords and whatnot. So, and again, so like I said, it's on the staging area. We do have a Redfish branch if you look for it, and we're definitely looking for feedback. So that's actually kind of where I end, and I pass my control off to, I think, John.
Okay. Okay, so you've been told what is Redfish, and there's been a lot of things I just want to clarify. So the Redfish runs on the BMC. So the groups that came together in 2014 and we released Redfish 2015 were all the people who built BMCs. And they said, yes, we need to go to a RESTful interface because that's what the industry wants. But we're not going to roll a BMC to support it. So whatever you do, it better fit in the existing BMC because we want it to be a firmware replacement load. And we're not going to wait a generation to add more memory to a BMC. So that's the first item. The second was why Redfish and why a modern interface? And basically it was feedback from data centers that basically said, yeah, you guys give us a lot of manageability, but it's all in this arcane language. And I can't take people who are doing production for me, using modern tools to do manageability. I have to go hire these special people who know the special language called IPMI and train them to go do it, and then they're stuck in their job. And they don't particularly like it. So what we really like to do is take people from the main line, go have them do manageability for 6 months, and then when they're done, go have them back to do the main line because that's where all money is. So the modern tool chains were pretty evident, right? It's HTTPS, it's JSON, it's Python. And they said, build your manageability at the end of that thing. So that's what we did. So you look at the IPMI specs, 400 pages. We've greatly reduced that, and most of Redfish is self-describing from the standpoint of once you get JSON, you can read it. It should be human readable as far as we're concerned. So that's the first thing. And I've heard schema back for quite a few times. The other thing that they told us was because we use modern tool chains, we use modern languages, we use this modern tool chain. So once you get a schema, we can go attach that to any tool chain we want. So when you do schema, do it in JSON. Use JSON schema because there's a tool chain behind JSON schema. We did it in OData CSDL because there was an Oasis tool chain behind OData CSDL. And once we had it out for a couple of years, Telco came to us and said, what about Swagger? What about OpenAPI? So in the last release, we released the schema in OpenAPI. And that's so people can go attach to a Redfish interface, extract the schema, and auto-generate. So with CSDL, I've seen a Microsoft tool which basically attaches to a new Redfish interface, extracts the schema, and auto-generates all the PowerShell commands needed to interact with that interface. And so that is the power of using modern tool chains, not the fact that we've done something different. Because at the end of the day, if you do the same thing another way, with power reset, setting reboot, people don't care about doing that. All they're doing is they're doing fine with IPMI. Why go to a new interface if it just does the same thing? So this interface allows them far more flexibility and far more efficiency in what they do. And that's why it's a value to people to go off and do this. Okay. Oh, second, so I represent Intel at the DMTF. I also represent them in the DMTF. I'm VP of Alliances, so I establish alliances with UEFI, with SNIA, with other organizations. And so I've heard a lot of discussion about compute in Redfish. One of the reasons I also represent Intel at OCP is because in the hardware management project, they're trying to establish a hardware manageability interface for all of OCP platforms. And OCP platforms span compute, storage, network, telco, HPC. And so I'm trying to establish a baseline there so that each one now has a baseline set of manageability all available via Redfish. And so that's a couple years off, but they're well on their way. So in March of 2018, they actually announced that direction to the industry, that that's the way they were going to move forward in trying to establish things. So if you look at who established OCP, it was Facebook. So Facebook has a BMC on their compute, their storage, and their network platforms throughout their data center. So the BMC is of interest to a lot of people because it provides an out-of-band interface. BMCs are powered by trickle power. So the minute you plug it in, the BMC can be up and running and watching the network for input. It also means that anything you do across the BMC, you don't have to go through an OS, which means you don't have to put an OS agent. You can go find your BMC and start communicating with it directly. It also allows you to help diagnose the system when the OS is down. So the areas, right, pre-boot and system hung where you cannot access the system, and where access to a BMC could help you determine whether you should wait for the OS to come back because it's in some wait state, or that the OS has not hit the watchdog for a while, and therefore it's probably dead, and you can hard reboot the system. Okay. So with that, when we released Redfish in 2015, the first feedback coming back from data centers was, if you're going to replace IPMI, you better have a host interface, because IPMI has a host interface. We built host interfaces are necessary for the host agent to synchronize with the BMC, so that there are no pools of data, that whatever the BMC sees, the host agent can also go see. So one of the first specs that came out was this host interface spec of trying to figure out a way for the OS to go contact the BMC. Previously had been done via some various IPMI specifications, various speeds. So we've established host interfaces built on top of HTTP. So security is a much easier discussion because it's just HTTPS. And once you say that, people can, the hackers will go down. They say, well, at least I understand where you're coming from, and we're not building a new security set of semantics. Okay, so the operating system can access us. There's actually code now running on Linux that can go through the host interface when it's exposed. And so this is the opportunity for the BIOS to also do that. Jason had mentioned the swath of data that the BIOS hands across to the BMC when it boots up. This is so someone coming from the outside who can only access out of band to the BMC can say, okay, what was all the data that BIOS found when it came up, right? Since the BIOS has handed this across in UEFI, then BMC can just say, well, this is what BIOS handed me when I booted up, right? You can have it too. Okay? But with the host interface, the BIOS can now interact and manage items within the BMC itself. Page now. Okay, so what is this host interface? So the host interface was actually done there were 2 stages. We got to the first stage, and we said, do we really need to go to the second stage? So the specification is already defined. It's been out for several years. And the first phase was actually, let's just do this as a network, guys. Let's go do a TCP/IP stack. Let's expose the BMC interface as an endpoint, and you can use your existing network protocol, since it's already built. You're already doing HTTP over TCP anyway. All you have to do is go do a local loop back to your BMC. The second phase was actually go do it MCTP. So this was the second protocol, which Jason had mentioned, which is the onboard protocol for routing network traffic on the platform. And so we never got to that. We basically looked around the room and said, anyone want anything different? And everyone said, nope, not yet. So we went with networking. Recently, information come back, right? Networking is nice, but it's a deep stack, guys. It takes a lot of processing power to go through the networking stack. Is there a faster specification we can go? And the answer is yeah. It's called MCTP. Do you want it now? And so the industry, I think, is about to push us to go do a second revision of the host interface, which allows you a much tighter interface to the underlying hardware. Okay, so don't be put off by the fact that this is TCP. It is the way it is because no one wanted to go beyond that. Any questions? Oh, I should wait for the end. Okay, so the process is for the UEFI BIOS to find this is to go discover the host, the management interface that the Redfish exposes. Since this is a network stack, we placed all the information necessary in an SM BIOS table. So if you can access the SM BIOS table, you should be able to extract this, and then you initialize the host side of your driver stack. Okay. Yeah, so implementations from an OS standpoint is OS implemented methods to find the host interface, advertise user space and applications. And so this is equivalent to the way Linux does things today over IPMI. And so my next couple of slides is a bit detailed, but it basically tells you what you should find in your SM BIOS table. So and new entries in the SM BIOS table 42. There's two, one to define the interface and one to define the protocol. Structure at the bottom is actually how the information cascades. So from that first interface specification, it tells you what type of interface you can go over. Currently, what's defined is across USB or across PCIe, and this provides you a much faster interface than the KCS interface that IPMI provides or the block transfer. Next is the protocol. So this is actually the establishment of the endpoint. So as you notice, it has your IP information, network information, and for IPv4, v6, depending on what network stack you want to use to get to your Redfish interface. So what the Redfish interface does, since it's RESTful, it's basically reduce manageability into a URI to get to your resource and a JSON packet. So based on that two pieces of information, you can get to any resource in the platform that we attempt to model within Redfish. So it's system one, processor one, do a get, and you can get your data. And each JSON provides you do a get, it gets you all that information. It also has action semantics, so that if you wish to post an action to something like reset a server, you can go to system1/1 reboot, and it'll go ahead and reboot the server. So we've dealt with both the extraction information and push information. Within the JSON packet, it's simple name value pairs or complex name value pairs. And it also has an OEM section for complex settings. And that way you can, with one packet of JSON, you can look at it and see all the standard stuff. And if you want to look at the non-standard stuff, you look within the OEM structure. The OEM structure can be isolated by whatever OEM wants to put additional data there. So as a client, you can say, I only want to deal with the standard stuff. You know, all this OEM stuff is all Intel, is all OEM proprietary, and I haven't got the code to go deal with that. I just want to deal with the standard stuff. And you can just grab the JSON packet, right? Ignore all the OEM stuff and just deal with what's standard. And that allows us to be far more interoperable between systems. And I think you're going to do security, Sam? Oh, well, Sam is coming up here. So Jason mentioned that there's not a whole lot of representation within the Redfish forum. Sam is your representation because he's the only guy I know who shows up. So he better represent most of what UEFI wants. Most other organizations that the DMTF interacts with actually forms a group within that organization that interacts and provides a quote official feedback to DMTF on what they want the DMTF to do. And so,
thanks, John. So with the Redfish host interface, since this is now crossing two domains, right? You have the BMC domain that has its own security boundary and its own access points and its own authentication. And you have the host, potentially your OS running or your pre-boot firmware running, and it's a separate security domain. So it's very important to worry about security when crossing between those two domains. So by default, and like John mentioned, DMTF tried not to reinvent security, right? So it's networking based, so it's HTTPS, TLS, well understood model with best practices of how to implement on both sides, right? From the BMC side and the host side. So by default, you need to authenticate to the BMC access with whatever BMC accounts you have with the privileges that are configured for that account. There are implementations, or there is a possibility of turning off the authentication requirements to authentication none. That was based on specific customer feedback. If your host environment is isolated enough, or if you are doing something quarantined, let's say during your initial deployment, you have to remember that this is a BMC configuration setting, right? So by default, the BMC will still require you to authenticate and log in. So to get to auth none, you have to actually log in to the BMC out of band using the normal methods and put the system temporarily in that authentication none mode. And that's not something that you would want to configure by default, of course. The last point about authentication is trying to solve this problem of bootstrapping, this chicken and egg problem of, well, I'm provisioning the system, I'm deploying, maybe I did my Pixie boot and trying to run my initial provisioning, and I don't have access to my BMC credentials, but I do need access to the Redfish host interface, just like I used to access IPMI over KCS, for example, to do my initial bootstrapping. That's an area that's still to be worked on. The spec as it stands today has a provision for temporary credentials that the BMC hands over to UEFI, and UEFI hands over to the OS in the form of UEFI variables. The OS is supposed to read them early on and then delete them, right? And then protect the access through an admin privilege in the OS. I think I see a lot of looks in the room, and there was a lot of looks at the spec. Yeah, Jeremiah is thumbing it down. So not recommended to be implemented if your OS is not doing the part that it needs to do for this solution, right? If the OS is not deleting the variables, then those variables are sitting around for anyone to read. Given, yes, they are provisioned once on every boot, and maybe they are not provisioned by default. Again, it's a BMC choice to provision them or not. But we are looking for alternatives. So that's an area where we could get feedback from this community, right? From this UEFI and pre-boot community. So if you have ideas, we're looking at feedback for DMTF, or we're looking at alternatives for this design. All right. Now let's look at some of the work that has been done so far in OSs and applications in implementing this host interface. Mike mentioned earlier that we have code now in the ED Code 2 staging that has a sample implementation. So that's on the BIOS side. You have some sample implementation, open source, that you can start looking at. We'll talk about the BMC side in a little bit, but now let's talk about the OS side. So first thing we did is we worked with the community, got DMID code to understand the new type. That's work we did with Neil Harmon from Red Hat, who contributed the code to DMID code. This is coming to Fedora, should be in 29, if I remember correctly. If not, it's coming in 30. And if you see the tables that John was presenting in a couple of slides ago, the type 42 describes the physical interface, and this particular Lenovo server that I tested this on, this happens to be a USB network device that connects the BMC and the host. So you have the USB device IDs. And then you have the protocol information, the networking configuration that needs to be configured on the host side so the BMC can communicate with the host, right? So the BMC may have, the BMC admin or BMC user may decide that this connection is IPv4 or IPv6, static IP, etc. So that information is relayed here to the host side in SMBIOS. So that's the first step. The next step is, well, we need OS code to find this interface and use it, right? Enable it for the user mode applications to start using it. So again, work upstreamed and led by Neil from Red Hat. Redfish Finder is out there. You can look at the code on GitHub. This is actually already packaged and approved for Fedora 30, so it's in the development streams for Fedora. What it does is exactly what it's supposed to do. It looks for SMBIOS type 42. It parses it. It identifies your physical network device that connects the BMC and the host, whether it's USB or PCIe. Both types are supported. There's a third type that's OEM that's defined in the spec. Well, the tool can't do much about OEM. So if this is running on an OEM implementation that doesn't use USB or PCI, the tool will need to be modified to understand that specific OEM implementation, but that's doable. So if it's USB or PCI, it finds the network device. It translates that network device to something that the Linux Network Manager understands. It then uses the Linux Network Manager to configure the network device according to what the BMC wants that device to be configured, the IP addresses and the VLAN, if VLAN was set on the device. And then finally, it adds an entry in your host's configuration for a Redfish-localhost. So now you have a Redfish localhost canonical name that you can use to access the Redfish interface directly from the OS with HTTPS/Redfish localhost. And the Redfish spec says you start with Redfish/v1. That's what's defined in the spec. And from there on, you can discover the rest of the tree and navigate it and do all these RESTful operations on the JSON to get and patch and post and do the actions and the settings, etc. Here is a demo of Redfish Finder working on a Lenovo server. I added there a link of where you can install it just because it's still hidden in the Fedora development streams. But like I said, this is coming to Fedora soon and coming to other distros eventually. Once you install the RPM, it's a user mode application. So you just run Redfish Finder. It uses DMID code. So it relies on the updated version of DMID code to also be installed. Uses DMID code, finds SMBIOS, finds the proper settings, uses Network Manager to configure the connection, and configure the network, and adds the Redfish host to the host mapping in the OS. And done. Now your BMC is reachable at Redfish-localhost. And if you look at what it did to my etc host file, you'll see that it added a Redfish-localhost name that uses the IP address. This happens to be probably a static IP address that was required by SMBIOS. If I look at the previous slide, right? So the slide was, this was a static IP address 169.254.95.18. That's what SMBIOS said to configure it at. So it configured the device at that address. It created the Redfish localhost, and it even mapped it to the out of band name of my BMC, which is in this case the Samer SR650, which is the domain name of the BMC, or the host name of the BMC on the other side of the network. Now that I have Redfish localhost, just simple curl command. Now it's the beauty of the tooling, right? We're using REST, we're using HPS, we're using JSON. The first access, by spec definition, the first access to the root resource of the tree is unauthenticated. That's by design. It doesn't give you much other than it advertises the service and tells you that, well, you need to authenticate to continue, and here are the things that you can do. So any subsequent access, let's say I want to follow the redfish/v1/systems to access the computer systems collection and then go down to information about this computer system or the BIOS settings, well, you need to authenticate from that point on with the BMC credentials. Another piece of work that happened also in the Linux upstream community is the addition of a Redfish plugin to Firmware Opt. So you all, or most of you, are familiar with Firmware Opt. Uses LVFS and the UEFI capsule updates to manage firmware updates on many of these laptops that are on these tables. The servers don't typically implement the UEFI capsule update, and servers usually rely on the BMC to do all the management, including the firmware updates. So Firmware Opt's approach was to implement a plugin that can tap into the host interface if it finds it from SMBIOS and be able to communicate with it and allow sending a file to do the firmware update through an HTTP transfer. There is still not complete synergy between this work and the separate work that was done with Redfish Finder, but there is room there for improvement. This is all upstream in terms of testing or extensions or improving the code is all within the hands of the community. Finally, well, let's talk a little bit about the BMC side of the implementation. So we talked about the BIOS side, the system firmware, the OS. Now what about the BMC? As John mentioned earlier, OpenBMC, which is a Linux Foundation project, has added Redfish support since OpenBMC 2.6 just recently. The code is all open source and upstream. There are continuous releases. It is in the backlog of the feature requests. So it's definitely, there is an ask for it, and the implementation should be coming soon. I know that OpenBMC right now is focusing on some of the out-of-band manageability through Redfish. In fact, firmware update is a big item that they are working on adding complete support for in the code right now. So once the host interface enablement is done through the BMC, then you can also tap firmware update through the host interface. So what is the call to action for this community here? Well, first, we'll implement this, right? A big piece of this is a firmware implementation in your system firmware, in the BIOS. You have some BIOS pieces, you have some number of protocols that need to be implemented. Even if you are not translating all your HI settings to JSON and transferring them to the BMC, that's great if you can do that, but even if you do the basic enablement of connect the BMC to the host by getting this information from the BMC, what is the network connection between the BMC and the host, and what are the IP configurations, and passing those along to the OS using SMBIOS. So that's the bare minimum that is needed from BIOS. And then, well, we need the OS community as well to implement this. Linux upstream code is there. Pick it up in your distros. Other OSs need to follow on. Once we have, and notice that a lot of the enablement is really can be done in user mode applications. So people are using it today using proprietary tools, and those tools is essentially the equivalent of having open source like Redfish Finder and having it a native or an inbox command built into the OS distro. But that work needs to happen, and then you can start running applications from the host side to take advantage of this. Is firmware update a use case? It seems to be, at least on some implementations. But are there other use cases? Well, definitely. Right? You can think of everything available in the BMC that you don't have access to in the host, whether it's the health information. The BMC is monitoring the hardware information, right? The BIOS configuration was the good example that was mentioned multiple times here, among other examples. And get engaged and provide feedback. So like John said, I myself, I'm regular at the DMTF, but there is both a working register between UEFI and DMTF. So there are rules and channels for communication just between UEFI forum and DMTF. So all of you are UEFI forum members. So you can use that channel of communication with DMTF. There are also many member companies in UEFI that are also member companies in DMTF and attend regularly and participate. In addition to those two formal methods, right, the UEFI forum and DMTF and the individual companies, there is open forum for the customers, for the end users, as well as the developer community to directly communicate with the spec authors in DMTF, including feedback, questions, bugs, enhancement requests. I can tell you that every single post on the Redfish forum is looked at weekly basis. John can attest to that. Spend a lot of time looking at every single question and answering every single question from the Redfish forum. A lot of the feedback that is provided end up being in the spec sometimes very quickly. So use that tool, get access to the standards, the open source tools that are available on GitHub, and get engaged. And that's all what we have. Do you have any questions?
So as a replacement to IPMI, when do you think Redfish can fully replace IPMI? And what's missing in between IPMI and Redfish now that needs to be done?
I would leave that up to the industry to decide. So what I've tried to educate the DMTF on is that it's a descriptive power. Its job in the universe is to describe as much manageability as possible, but it has a hard time trying to prescribe what people should or should not do because DMTF standards don't appear on RFPs. So the only people with prescriptive power in the universe are those that appear in RFPs shipped out by data centers. So OCP, the Open Group, other organizations have the prescriptive power to mandate industry go in this direction. So from a DMTF hat standpoint, don't know. It'll happen when it happens. We've already stated, we've already got the IPMI promoters group to state that no further updates will be made to IPMI. Go find yourself a better interface.
So rate of adoption of Redfish. On compute nodes, on servers, I would say it's close to universal on servers that have been shipping in the last year or two. Retrofitting in older models, and that's maybe part of the problem as well, is that servers' life cycle is longer in data centers. Retrofitting in old models is harder, so you'll see less of that, more of new machines that are shipping.
So I would say in 2015 when Redfish came out, there were 2 vendors at the door waiting and pushing us to get this release so they could ship their Redfish implementation.
So there are competing host interfaces defined by the DMTF, like the Redfish host interface and the MCDP host interface. One is like Redfish host interface, as you mentioned, it's a heavyweight component compared to MCDP host interface, which is kind of a lightweight component. Is there a plan to kind of push MCDP host interface as well sometime in the future?
The DMTF is a volunteer organization. Anyone who wants to come in and pick up a pen is willing to do so. That's why I mentioned that it was actually done in 2 stages. We were going to do network, and then we were going to do MCTP. And when we looked around the room for anyone who wanted to do MCTP, everyone stepped back. So we said we will suspend the work group until someone wants to pick up a pen. So at some point when performance becomes a problem, someone will pick up a pen.
Yeah, and to clarify where we are today, so if you look at the pictures, the host interface requires TCP today and HTTPS. That's the Redfish host interface. MCTP as a host interface is still in use for lower level data transfer, right? So Jason mentioned PLDM and Redfish device enablement, which is a way of the I/O adapters to transport their configuration and their firmware payloads and update firmware directly to the BMC. Well, that's using MCTP, and that's also from DMTF, standard from DMTF. So what John is saying, if you want to see MCTP in that red circle, you need to step up. The current feedback from the industry community was, well, okay, it's good, secure, networking. Let's get that started. Maybe that would be the next phase.
One more question. When using Redfish host interface, a network, USB NIC, for example, it can be used both from the firmware as well as the OS side, right? Does the spec define who takes the control? Is there like
HTTP is stateless, so it's kind of whoever comes in, comes in. So both of them establish a HTTP session to Redfish.
Okay.
So it's whichever sequentially comes in. So if there's a need to block or have priority on one to the other, that's a simple thing to go figure out. Most of security within Redfish, not only does it have certificates, but it also has authorization roles. So you can actually have a UEFI role, if you wish, and a kernel role, if you wish.
Yeah, not all access from the kernel is going to necessarily give you 100% the access that you get on the outside of the world network, on the out-of-band network. You can configure all of that based on privileges.
Oh, I have one question. Is what is the difference between the host interface and the sideband interface?
So like we said a minute ago, the host interface is a well-defined standard Redfish host interface with SM-bias discovery. And once you do the discovery, you have HTTPS that gives you access to the Redfish REST API. The sideband accesses between the BMC and the hardware, some of them are standard, like MCTP, which could be over PCIe or could be over I2C or other transport, and they are used for other types of data transport. In the case of Redfish specifically, there is data transport between the I/O devices and the BMC that is PLDM packaged encoding of the device configuration or the device firmware payload to the BMC. But that's happening outside the direct Redfish service, the HTTPS Redfish service. And it's the BMC's job to take that data as shuffling on the sideband over PLDM and make it available through the main interface, the Redfish interface, both the inbound, the host interface, and the outbound.
I'm still not
So
very
you
clear.
can see the BMC as a northbound interface, which is exposed to either the host or off platform, and you can see the southbound part of the BMC as interacting with the underlying hardware. So you can go reboot a system from the outside via Redfish. BMC needs to translate that to talking to the processor to get to reboot. So the underlay of all this is what's called the sideband interface. And so the DMTF defines Redfish for northbound, outward, why it's chatty and Redfish-like. And for on-platform, it defines MCTP as a transport and PLDM as a data model. And that's all for on-platform communication between the management controller, the BMC, and any device on the platform. So it can talk to the drive, the PCI switch, anything on the platform itself.
If I understand correctly, for sideband access is actually only one-way access. Only BMC reads the hardware.
Correct.
Okay.
So I2C, SM bus, all that stuff is southbound.
Okay, thank you.
Question, does the Redfish host interface definition allow for the possibility of multiple interfaces?
Yes, there is allow for multiple protocol instances on a single interface. So you can have like IPv4 and IPv6 on a single interface, as well as allowing multiple interfaces. There is an area in the spec that is confusing people when we started looking at some of the implementations, especially that SM-bias doesn't let you to package a lot of data in a single structure. Still has those 8-bit length fields. So that means multiple SM-bias instances, and we're working on some clarification in the spec to help people decipher that, right? If you see multiple instances, how do you map what is multiple protocols on a single interface, or describing multiple host interfaces in the system, because in theory it's possible.
So one question with the FWUPD update, server which host interface is the updates capsules coming over?
So the current work that was done in FWUPD is not necessarily capsule based. It is just a plugin that allows a binary blob to go to the BMC. Could that binary blob be capsule? If the BMC accepts it, yes. Could that binary blob be proprietary? FWUP doesn't care. So it doesn't give you the full functionality of FWUP that capsules does give you today. Definitely far from full. It's just a way to, like I said, take a binary blob and send it to the BMC to do an update.
So the MCTP, right, PLDM, I talked to you offline already, but how much of the adoption rate is for those type of protocols?
So for I/O devices, for PCI adapters, definitely that run on servers. Just based on my experience with the partners that I work with and people that come to our testing suite up there, I would say 85% for the PLDM firmware update, because that spec is a couple of years old. The Redfish device enablement spec is brand new. It's still 0.9. So what the MTF does is they publish specs before they are final, unlike UEFI forum, but they publish a specs to get community feedback before the spec is finalized. So it's published as a work in progress version 0.9. There are no implementations today. Although I could see people that have already implemented PLDM with firmware updates to be, that's their next wave of firmware improvements to add the RDE support. And remember, RDE gives you configuration, PLDM for firmware updates gives you only firmware update. And the number that I mentioned does not necessarily cover drives. I don't know if you want to talk about the NVMe partnership or anything else.
Yeah, so there's the BME MI management interface group that we actually went with when we did firmware update, and they said, you know, BME MI just went out. We're busy trying to make sure it succeeds. We don't want it to perturb it at all. Come back in a couple of years. And so last year, both SNIA, NVMe, and DMTF formed a three-way alliance to make sure that we could translate a command from Redfish all the way down to a BME device as seamlessly as possible. So that's still in progress.
So you mentioned earlier about the MCP host interface, and you said that there might be industry pressure for that to come back and be a thing. And I suspect the answer might be a pen. We need a writer again. But I was curious. You talked a lot, so Sammy, you talked a lot about the authentication story in the normal Redfish host interface. So is there an authentication story for the MCP host interface?
About that BMCI work, work in progress published. I can mention that there is. We are trying to remember if it's published on the website or not for the MTF confidentiality. Yeah.
So there's a draft set of slides about what we're trying to do, but we're trying to create a security object that can be passed within the platform, so we can verify all components within the platform and communications between them. And MCTP it's based right on top of MCTP. So.
Yeah, so if you are a member company of DMTF, you can log in and see all the gory details. And if you are UEFI member company, you can get some copies of specs that are work in progress. And if you are public outside either domains, you can go to dmtf.org and you will see at least the slides that John mentioned of the work that's happening there. All right. There are no questions. We will be available for any other chat this afternoon. Thank you, everyone.